Welcome to the third of these little shows for the exponents and surds revision in my class. First one here, we have to express the following with positive powers. I'm just going to rewrite this one as 2 multiplied by r to the power of -4. It's just going to separate these two sections here. The power is only applicable to the r and not to the 2. So that's why I've sort of separated them a little bit so that you can identify which is which. Now if we have a negative power, we'd flip it down to the bottom. So if we have x to the -1, that is equal to 1 over x. If we have 2x to the -1, that will be equal to 2 over x. In this case here, it'll be equal to 2 over r to the power of +4. That's the answer. The second one here, we have the negative power on the bottom, so in this case we need to flip that up to the top and give it a positive power. So this would be equal to 5m to the power of +3. A little bonus question I might give you in here is if we had 2x to the -1 over y to the -2, everything with a negative power gets flipped either to the top or the bottom. Anything with a positive power will stay where it is. So the 2 is a positive power, so that stays on the top. The y is down the bottom, it's a negative power. We'll flip it to the top and give it a positive power, and then the x we'll put down the bottom. Okay, next move to the next slide. We need to simplify these. In simplifying these, we're going to see if we can find a perfect square that goes into the number. So for the first one here, if I go through my list of perfect squares, one that goes into 25, and I'll just draw up a little list here. So we've got 1 squared is equal to 1, 2 squared is equal to 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared equals 36, 7 squared equals 49, etc. If I look at 125, that is equal to 25 times by 5. I can now simplify this. The square root of 25 times by the square root of 5. The square root of 25 is 5. And I can't do anything with the root 5, so I'll leave it as root 5. So the square root of 25 is equal to 5 root 5. Now similarly, this part B over here, this will be equal to 2 times by the square root of 72. If I look down here, 36 goes into 72 twice, so it's going to be 36 times 2. So that's going to be 2 multiplied by the square root of 36 times by the square root of 2 equals 2 times the square root of 36 is 6. So now we have 2 times 6 is 12 root 2. And we'll move on to the next slide. This one's looking a bit nasty. What we'll need to do here is firstly simplify where we can. So if I look at the fraction inside the surd, 4 goes into both of those. So 4 goes into 25 times. 4 goes into 32 8 times. So this is now going to equal 5 square root 5 over 8. Which is the same as 5 times the square root of 5 divided by the square root of 8. Now when we're simplifying, we like to rationalise the denominator. So in order to rationalise the denominator, we just take the surd which is down the bottom, we'll multiply both the top and the bottom by that surd. So this will be equal to 5 times by the square root of 5 times 8 over the square root of 8 times 8. That's just multiplying this one through. Let me see if I can squish this up a little bit. A bit more room now. So that'll be equal to 5 root 5/8 of 40 over the square root of 64, which is equal to 5 root 40 over 8. Now this root 40 would need to simplify that, so I'm just going to bring that up here. So we've got 5 root 40 over 8. We need to simplify the root 40. What's a perfect square that goes into 40? 40 is equal to 4 times 10. So 4 is a perfect square. That's the biggest one that will go into it. So we need to now deal with that. So that's equal to 5 times the square root of 4 times 10 over 8, which is equal to 5 times by the square root of 4 times the square root of 10. I'm doing all these little baby steps in here. The square root of 4 is 2, so it's going to be 5 times 2 times root 10 over 8. Now, what I'm going to do is simplify. The 2 will go into the 8 4 times. That cancels that down. So that will leave us with 5 root 10 over 4 as the answer to this one. Doesn't look that much simpler than the original starting question, but we've got rid of the surd component down the bottom. And that's the end of this little presentation. See ya.